Question 12.41 from the homework is a little bit more challenging. We're given the following information. We've got a 2.11 gram sample of a non-electrolyte dissolved in 53.4 grams of water, and that solution freezes at a temperature of minus 1.23 degrees Celsius. With that information, calculate the molar mass of the solute. So again, they tell us quite a bit of important information in the question. They tell us it's a non-electrolyte. So we know the Van Hoff factor is 1. It's dissolved in water, so we know our freezing point constant is 1.86 degrees Celsius per mol. And we also know our change in our freezing point. Our change in our freezing point is minus 1.23 degrees Celsius. So taking a look at the equation, delta TF equals negative I KF times molality. So our change in freezing point equals our negative Van Hoff factor times our freezing point constant times the molality. We know our change in freezing point. We know the Van Hoff factor, the freezing point constant. We can find the molality of this solution. So that's step 1. Find the molality. So my freezing point, my change in my freezing point is minus 1.23 degrees Celsius. My Van Hoff factor is 1. My freezing point constant is 1.86 degrees Celsius per mol times our molality. So we're going to divide across a negative 1.86 degrees Celsius per mol to see that the molality of this solution is approximately 0.661 mol. Molality is moles per kilogram solvent, right? Moles of solute per kilogram of solvent. So now we know the molality. We can find the moles. So I have a 0.661 mol solution, which is 0.661 moles per kilogram of solvent. I don't have a kilogram of solvent. I have 53.4 grams of water. So we need to convert that mass of water into kilograms. So I have 53.4 grams of water. I know that in 1 kilogram I have 1,000 grams. So I divide that by 1,000, and the mass of my solvent is 0.0534 kilograms. I'm looking to get moles, so I'm going to multiply by the mass of that solvent. I multiply by 0.0534 kilograms, and my mass cancels out and leaves me with approximately 0.00353 moles. Now we have to find the molar mass. And fortunately, we know moles equals grams over the molar mass. I know moles of my unknown, and I have grams. They tell us we add 2.11 grams of our unknown. So I have approximately 0.00353 moles, and that's represented by 2.11 grams of the unknown over my molar mass. So I rearrange this equation to see that my molar mass equals 2.11 grams divided by 0.00353 moles. Divide that through, and the molar mass for this unknown comes up to be approximately 59.8 grams per mole. So we started with our change in freezing point. We used that information to find the molality, and then we used the mass of the solvent to find the moles. And then once we knew moles and then the mass that we added to that solution, we could use that information to find the molar mass of the unknown, approximately 59.8 grams per mole.